You can don't do it during the talk, but later if you want, do a Google search for simple programming languages or simple programming or simple whatever, and just follow your nose. And the reading is downright hysterical. I'm going to share some samples of that. So people use simple to mean a lot of different things. One thing that it often means has something to do with keeping count. Right? It's a score-keeping thing. So having one of something is simple, and two of something is somewhat more complicated, and three of something. And in fact, some of you probably remember the interminable thread on the Google group. How many people read this thread? Right? The title of the thread was "Simple Things Should Be Simple." And it was all about the stuff that Chaz would really care about, right? It was all about automation effort around shipping some simple hello program, right? The basic automation. And it was all about counting, right? How many lines? How many lines are this? How many lines are that? How many are boilerplate? How many tools? It was all about counting. And the presumption here is that a small count is simple and a big count is complex. Well, let's think about that. There's a bunch of arrows all connecting something or going in one direction. That's pretty simple. And if I add more arrows, pretty much the same amount of simple. Hat tip to Rich for this example. Then I go and add one of them or two of them route in a different way. Right? And that starts to be complex. And obviously, if I wanted to take more time in Keynote, I could make this really complex, right? We could have more and more things. But the complexity here is coming not from numbers, it's coming from interactions and varieties of interactions and things working in different ways. Another thing that people talk about when they talk about something being simple is maybe beginner friendly. So there's a great quote here from the O'ReillyNet blog. The most important gauge of any programming language is how easily a novice programmer can maintain a significant program in any problem domain. Wow. I just want to let that sit there, right? Somebody actually stated this, and it was not on April Fool's Day. Pick any profession you want and translate that. Right? The most important gauge of any basketball playbook is how easily a junior varsity high school athlete can compete in the NBA finals. Right? This is the most, it's a wonderful example of that whole sort of in 21 days for dummies school of thought. And in fairness to O'Reilly, I don't think that is widespread at O'Reilly at all. But since we're named, it's the end of the day, it's rant time, so we'll do name calling. A related one, and this one actually has the word simplicity in it. Simplicity should be fairly simple to read, learn, and understand. Python is good. PHP is great. C++ and Scala not so good. Well, one of our own who's here today, Brenton Ashworth, I think had a quote that for me really undercuts this sort of ease of learning argument. Right? If you were really concerned about ease of learning, and that was your primary measure for something being, insert any positive thing here, where are you going to end up? And I think that ease of getting started is certainly a value, right? That's absolutely something that, well, I shouldn't say absolutely. This is one of the problems about doing a weenie talk about words is you become incredibly paranoid about your own words. So let me retract the word absolutely. It is certainly in many settings of value that something be incredibly easy to learn. I would argue that one thing you could sort of tweak that value a little bit is that if I'm going to pick a hobby that I'm going to spend a few hours on, it would be really nice if that was easy to learn. Right? Plants and Zombies is great. Right? You can learn that extremely quickly. It's not a really good basis for building a career. Right? Being able to learn something in an hour doesn't seem to be a good way to build a career. Of course, given that we're talking about Clojure here at the conference, I would be remiss not to talk about syntax for a moment. Because there are a lot of conversation about simplicity that is about syntax. And so you get this great quote. We need constructs that are natural to humans, not mathematics. This is actually a sub-bullet point to simplicity. And the construct should be consistent with the normal, average, non-mathematically trained brains. The red highlighted words are the places where this is at maximum bullshitness. These are all words that people throw around rhetorically. Right? These are all words that people throw around as generic positive. Right? Anytime you see the word natural or normal or average, non-mathematical is a little bit more domain specific, but natural and normal and average are all rhetorical trick words. Right? They used to have some meaning in the deep darkness of time, but it's gone, whatever it once was. And so this is basically, we're going to pick one word, simplicity, and then we're going to sort of weasel that with a bunch of other weasel words. Another one that's good is minimal. Maybe simple is minimal. And so you get this nice quote. If the semantic model of a language is clear, if the rules are simple and precise, the language will be more productive to use. Less is more. That's actually not half bad. It has nothing to do with simple. But it's not half bad. The amusing part of this is that this is from a technical article explaining what language? Java. So minimal is valuable, but I don't want to really stop there either. Uncomplicated. Maybe simple is the opposite of complicated. Some of you have perhaps seen this cartoon, which is a great cartoon. So if you can't read the red boxes, the product on the top is an Apple product, which just has a button. The product in the middle is a Google product, which just has somewhere you can type in the find button. And the picture on the bottom is your app. So these things are all, this matters. I think this is a great cartoon to show anybody who's doing usability design. If you're worried about usability, this is a great image. This is from Twitch, if anyone doesn't read it. It's a fun cartoon on occasion. And I want to be clear that a lot of these things that I've talked about, when people use the word simple to describe it, I don't think for the most part that they were being malicious. They were actually doing malice to the word simple. But they were actually trying to state something that they wanted. And to some degree, the things that they wanted, possibly put up against other constraints, were good things. Right? How many people want their programming environment and the tools they use to be convenient, friendly to learn, easy, familiar, minimal, and uncomplicated? That all sounds great. So, interestingly, one conclusion that you might come to after looking at all these things is, I give up. It's hopelessly subjective. And I've been grabbing all these quotes from blogs and the web. The great thing about the web is it's sort of like the Lorites, right? Anything that can be thunk has been thunk before. And so I wasn't the first person to think this. Maybe we should just give up, right? So one man's simple is another man's complex. This particular blog post was from a person who took umbrage to Martin Fowler's refactoring book. And the particular thing was that the conclusion that they came to was that 90% of refactoring was making things shorter. Those of you who work at Relevance remember back in the day when I said that no function or method could ever be longer than 7 lines, and if you showed me one, I would prove that it was wrong in some way. So I haven't, on occasion, been on the Martin Fowler side of this conversation. This actually harks back to an earlier implied definition of simple, though, doesn't it? Right? It was about count. Right? This is a counting, sort of a counting characterization of simple. If it's got a few things in it, it is therefore simple. If it has a lot of things in it, it's the opposite of simple. Which, since we haven't defined simple yet, I'm not going to leap to conclusions and say what word would be the opposite of it. This is not correct. Right? Simple is not subjective. Simple has an objective definition. The definition informs designs. And that's really important, right? This, not only does it have an objective decision, but you should care about it if you write programs. And unsurprisingly, right, none of this is Clojure specific at all. Right? Everything I'm going to say today, to the extent that it is useful at all, is going to be useful in Clojure, but also outside. Also, simplicity is fundamental. So what does it mean? It's actually, literally, quite simple. Simple means not compound. That's it, not compound. Right? And in a lot of the original usage, this notion of being not compound was literally like compounds, medicines. Right? And so medicines that were made of one thing were called simples. And people who went out and looked for them, there was actually a verb, right? Simpling. Right? I'm going to go out and do some simpling. Right? I'm going to go find some simples that I'm going to use to treat your rash or whatever. And so how did we get from this, which is a terrific definition, and we're going to do all sorts of fun things with this. How did we get from simple becoming so complicated? You think the beer? Oh, I do not plan to wake up tomorrow morning with any major problems solved. So, in order to understand this, we need to turn to one of the greatest programming minds of the 20th century. C.S. Lewis. Little known fact. So on the left here we have a nice picture of C.S. Lewis, and on the right we have this wonderful book called Studies in Words that C.S. Lewis wrote. Definitely pick it up on Amazon. Play this game to see which speaker can get most people going over to Amazon buying stuff. And on the right there is a bottle of really peaty scotch. That's just product placement. It actually has nothing to do with the talk. Actually the book was next to it in my office, but other than that, just coincidence. And a key element that informs this book is the notion of verbicide. Now, in a Clojure context, we're used to thinking nouns and verbs and kingdom of the nouns versus functional programming, but actually, verb itself has kind of been verbicided, right? Because verb, where does it come from? It means word, right? Verbum is word. And so verbicide is actually not the killing, and C.S. Lewis being a language weenie, verbicide is not the killing of verbs, it's the killing of words. And the specific killing is, in his opinion, is the fact that people are far more interested in expressing their opinion, especially I approve or disapprove of this message, than they are in evaluating and describing and being analytical about things. And there are a lot of great examples of this in American English, a particularly potentially politically incorrect one, and I like to use those in my talks, is that in English, at one time, there were a bunch of specific terms for different kinds of mental defect, right? They had meanings, right? So idiot and moron, and many of these words, if you actually look up their origin, they actually had definitions. Now, the social science and IQ testing and so forth that supported those definitions may or may not be well-founded, but they had specific definitions. What do they all mean now? I don't like you. They don't even mean anything about your intelligence, right? They just mean I don't like you. And in that context, you can sort of understand what simple is. Did simple become a generic term of praise or a generic term of disapproval? Trick question. It kind of became both, right? So let's look at how the original definition of simple ramified over time. We start with not compound, and then we get sort of three branches. The first branch is unconditional. So you have the notion of simple as being unconditional, the thing in itself. And so you say, to really abuse words, Clojure is simply awesome. Right? What does that even mean? It's right. Clojure is generic praise word, generic praise word. Right? It is in and of itself awesome. And it actually is very difficult to come up with things that are in and of themselves good. C.S. Lewis, as a devout Christian, his examples about this, of things that were true in and of themselves, were usually religious examples. So he would say that, God is simply good. Chocolate is good to me, but not to my dog. Right? So chocolate is not simply good. There is a second branch of evolution of the meaning of the word simple, which is not duplicitous. And this one has a really amazing series of transformations. You go from, I'm not duplicitous, right? I'm not of two minds. I'm not of compound mind, if you will. I'm not duplicitous. I'm not guileful. And in fact, if I'm not guileful, what we know about people who are not full of guile is they don't tend to notice guile in others. Right? So I'm unaware of guile. And actually, I'm credulous. And then by the time it's finished being dumbed down, the word actually just means stupid. Right? So you are a simpleton. And then finally, you get the beginnings of the meaning that people are scratching back at a little bit when they use simple in debate, and that is uncomplicated. And the uncomplicated meaning is actually complex in that it has multiple sub-branches. Uncomplicated goes towards easy. Wow, it's so simple to do that. It also goes to not posh, right? I live in a simple home, that sort of thing. And the not posh one sort of further branches to, is it a positive or a negative distinction to be posh, right? And when I say my home is simple, am I saying it's poor and second rate? Am I insulting myself? Or am I saying, humble in some sort of positive way? And all of the senses of simple under the not duplicitous branch and under the uncomplicated branch kind of eventually head down to sort of this general appealingness and disarmingness. And so simple becomes an emphasis word that is inoffensive to the extent that whether it's positive or negative, it's unthreatening, right? So I am a simple man, right? There's some small positive notion to that, probably, depending on how I say the word, but it really is just a generic term. And all these examples really aim at the part of, when you start using the word in these ways, really aim at the part of rhetoric, which is called pathos. Right? We've gone from appeal to analysis to appeal to what? What is pathos? Appeal to emotion, which there's nothing wrong with. There's nothing wrong with appealing to emotion. Appealing to emotion without having anything else is somewhat pathetic, which is related to pathos. Now, I just want to make a tiny digression, which really floored me when I was rereading Lewis's book, because I didn't really realize what a computer programmer he was. Right? It's not something that people generally talk about, but he makes the observation, the specific observation, that how words grow like this is a persistent data structure. He actually says words grow as a tree. Right? What does ramify mean? It means to branch out, but the original nodes are not gone. You can still access them. You can still get back to the original meaning. And so Lewis is quite specific that words evolve like a tree. They do not evolve in a mutational way, right? They do not metamorphose in place. And so one thing I want you to go away from the Clojure conference realizing is that mutable programming is like liking mosquitoes better than trees. Right? Things that metamorphose in place are really mosquitoes.
You got another one of those?
Another hour. So we can talk a minute about mainstream object-oriented programming. And in mainstream OO, objects are compound. They're the opposite of simple from our definition, right? That's the dichotomy that I'm laying out here, simple versus compound. And objects give you a lot of stuff. They have methods, they have polymorphism, they have types and interfaces, they have namespaces, they have structure, they have uncontrolled mutation in most languages. And it's difficult to explain Clojure. Some of you are probably going to go home and want to explain Clojure to an object-oriented programmer, or convince a team of object-oriented programmers to give this a spin. And it's not particularly constructive to say Clojure rocks, OO sucks. Or to say OO rocks and Clojure sucks. Right? I mean, the whole notion of being passionate about simplicity would be to say, let's break it down. Clojure does not stand diametrically opposed to all of these things on this slide. In fact, it's not opposed to very many of them. right? These are, I mean, there's a ton of good stuff in OO. But the good things in OO are delivered, in most languages, in a fashion which is both complex and complicated. Right? So features in OO are delivered as compounds. Right? You get objects and they have all those things built into them. Those compounds tend to contain more than you need. Right? It's actually rarely the case that you would need everything that objects give you, say in Java. And this snowballs from the language into the libraries. Right? Using OO with all these features compounded together leads to a snowballing of complexity and complication in libraries that are built in this pattern. What we want is the goodness of objects, but we want it delivered a la carte. We want it delivered as simples. And if you look at what Clojure does, and this doesn't really need to be stated much to this crowd, it delivers every single one of the features that objects delivered in the other picture, but it delivers them a la carte. And so I've drawn all the pieces spread out, and then I have also added a dotted line around the foundation. What is the one thing in the OO world that we absolutely just stand against as Clojure programmers? The uncontrolled mutation. Right? The other stuff is fine. It's a positive good, right? But we want to have it delivered a piece at a time. The other thing is we're going to have an interesting discussion about the relative importance of different things, right? And maybe you don't agree with this relative importance. We can talk about it over beers later. But we have a foundation and we have a superstructure. Now, let's talk about this with a few specific examples from Clojure. So it's well and good to draw a picture, but it may help to see some particular examples. So polymorphism. Polymorphism is delivered a la carte in Clojure via protocols. And so this is from a recent check into Clojure, the diff protocol. Diff is a generalization of equals. So instead of the notion of I want to compare something and find out yes it's equal or no it isn't, I want to compare something and I want to find out what's different about the first thing, what's different about the second thing, and what's shared by both things. Right? So diff, the function, which you actually don't see here, does that. And then the notion of comparing things for difference is actually built around being able to compare the different equality partitions in Clojure. And it turns out that set, list, and map are the three pieces that are needed in this particular case. But the thing that's going on here from a simplicity perspective is that the protocol is being delivered as a simple, a la carte. It's not being compounded back into java.util.set. It's not being compounded back into java.util.list. It's not being compounded back into java.util.map. I'm not going to beat up on this because anybody who's been awake for the last 2 days, who already talked about this? We had a whole talk. Right? Sean talked about protocols yesterday. Right? He made some of the specific points about what's good about delivering this as a simple. Right? We extend to existing types, and I do want to talk about one side effect, though. One thing that falls out of this, because this was kind of surprising to me as we started to use protocols inside Clojure, that the implementation contract is not equal to the call or API. That can be true in a Java or a C# app as well, right? We can have, and then you would call it adapters or bridges or who knows what design pattern. But it just falls out of delivering things this way, that diff similar is not a function that any client's ever going to call. They actually call a function diff, which delegates under different circumstances to diff similar and other things. And that notion of using protocols as the implementation contract is a positive consequence of having delivered a simple thing to begin with. Right? It's a side benefit, if you will. Namespaces. In Clojure, names, the naming of things is a la carte through vars. And so a name could just be a raw name. It could point to data. It could point to a function. It could point to a class or to a polymorphic function. And namespaces themselves are mere maps. I substituted the word mere in for simple, realizing that I was getting myself into some sort of recursive trouble there. The namespace piece is really powerful because if namespaces are a good idea at all, it's nice to have them available everywhere to everything else. Implementation reuse is delivered a la carte. So if you look at, this example is taken from clojure.java.io. If you look at the stream implementation, it is a map of keys to functions, and then various classes, like buffered input stream, have the protocol I/O factory extended to them using that map, but also not having to have a special mix-in API. Right? There's no special API for mix-ins with Clojure protocols. What's the API? It's the collections. Right? This is a point that Mark McGranahan made earlier today. Right? This is exactly the same point that he was making about Ring, that because things are built out of simples, they're built out of values and functions, you don't have a special API for building mix-ins. Now, you might choose to write a collection processing function of some kind to help you make mix-ins, if that use case came up, multiple times. And that thing wouldn't be simple. And I would talk about that in terms of creature comfort and convenience. But you don't have to. Syntax again. Given it's a list, we have to keep coming back to this. This one is particularly funny because the proponents and detractors seem to agree. This is Paul Graham. And you can't see it from this quote, but the context should be followed by Lisp is simply awesome. Right? Lisp looks strange, not so much because it has a strange syntax, but because it has no syntax. This is from a blog post that could be summarized as Ruby rocks, Lisp sucks. And it says the problem with Lisp is that it doesn't have syntax so much that it has no syntax. This being a rocks, sucks kind of blog post, it also uses a lot of other words as generic terms of praise or criticism. It uses the word technical to mean bad. It uses the word regular to mean good, the word sensible to mean good, and the word clean to mean good. So if you really wanted to take the amazing thought that went into this pro-Ruby anti-Clojure argument, you could actually reduce it to Lisp sucks because it's technical, and Ruby rocks because it's regular, sensible, and clean, with none of those words defined. By the way, it's a rhetorical trick on my part, right, as I'm telling this story. Right? Have I said anything about how much Clojure or Ruby actually rock or suck? I haven't said anything. Right? I've maybe moved you slightly emotionally, like anti some hypothetical Ruby people you don't even know. Right? So it's like a character assassination of some person. But I haven't really proven anything here. I'm not being analytical, right? I'm drinking a beer and it's a Saturday afternoon. So in what way, though, is syntax simple? It's simple in that in a particular setting, you have only one thing in play. You don't have a compound in play. So when you look at, this particular example is true for Lisps in general, right? Open parentheses followed by verb. And so people who find Lisp's simplicity to be beneficial appreciate this, right? It could be a function or an operator or a method call or an import or metadata or control flow scope. It doesn't matter. Open parentheses, verb, go. A second example, Clojure specific. Bindings. Right? Bindings are always housed in a vector. And this is a particular point you want to make when someone's talking about all the irritating parentheses. Right? Clojure is not full of parentheses. And in fact, it uses different punctuation in order to enforce simplicity. Right? So when I see square brackets in code, I know that names are being bound to something. And all these things work in basically the same way. Right? And in particular, they have access to what? What is Clojure's amazing sleeper feature that looks really creepy when you first start but just grows on you? Destructuring. Right? These all get access to the same goodness because of that.
Not binding.
Not binding. Right? So I will point out, here's the advanced version of the conversation, which we can't have here. But there are two wrinkles to this particular slide. I actually have notes at the bottom of the slide, which you can't see. There are two wrinkles to this. One of the wrinkles is binding, which doesn't let you do destructuring. And there's a reason for that, and it's still simple. Or actually, you could argue that it's complex and warranted. Also, fun and deafin are different from the others. And there's a more elaborated version of the simplicity argument that I think is in play there as well. But we don't have time for that now. So argument from authority, it's simple. This is a particularly good one, and this is one that I flubbed the first time that Rich and I were teaching together. I was conflating in my vocabulary REPLs and shells. And everybody, almost everybody does this. Actually, somebody was wrong on the internet about this just like 48 hours ago. And it's been all I can do to not go on the internet and try to fix it. But there was, I think it was probably some of you, if you follow the Clojure hashtag, it was some Python programmer's first reaction to Clojure, and then the Hacker News thread. There was a big conversation about whether the REPL was special to Lisp or not. And in the entire conversation, it was clear that in the minds of both the pro and con arguers on the point, that REPL and shell were synonymous. Well, REPL and shell are not synonymous, and they are both compound things. Right? Neither one is simple. However, which one is made of simple things? The REPL. Right? A REPL is one of my favorite things in Clojure now because it has an acronym to remind you that it's a compound of simple things. What simple things is it made of? Read, eval, print. I don't want to spend a lot of time beating up on the fallout of failing to be simple, because I think as the Clojure crowd you probably already have felt this pain, and that's perhaps why you're here. But just think for a minute about what this, I mean, this maybe doesn't matter very much in arguments about the shell versus the REPL, but what is the fallout from not perceiving R, E, and P as being different things? What do you end up with? Well, okay, the reader converts serialization into data structure. Eval does stuff, and P prints stuff. If you don't have R and P in your world, if you lived in a bereft world without R and P, you would have to invent data interchange formats. Right? All of JSON and XML and all of the problems that they cause fall out of not understanding this distinction. And you've probably heard Lisp programmers complain that we invented S expressions 50 years ago, this XML stuff is silly, which is a whiny way to say it, right? Because it's important, and it's too easy to discredit them when they say it that way. But it's important to, it's only understood to be important when you realize what the fallout of this is, right? And not only is it not simple, it's also, in my view, a stratification problem, right? That if you don't have reading and writing of data structures at the bottom, then rediscovering that later, it's upside down. And it causes all kinds of problems. I mean, how many people have ever seen a website that got burned by somebody evaling JSON because they didn't have a reader? Right? There's a ton of downstream problems that come out of this. Now, what about vars? Clojure vars actually suck, right? And why do they suck? They suck because they don't deliver this promise of simplicity. Rich laid out 4 things that vars might let you do yesterday: rebinding, error handling, redefining, and global mutable state. And as they're delivered today, they are less good than they could be, right? As they're delivered today, vars are rebindable. You could rebind them for error handling. You could redefine them. You shouldn't use them for global mutable state. Fine, we're not going to worry too much about that. And the code that he talked about yesterday, the changes that are in master now, make rebinding and error handling one simple, and redefining a different one, right? Redefining is one use case. It's supported by def. Rebinding and error handling are one use case. They're supported by dynamic. Now, you can all count. So somebody should probably raise their hand here and say, well, Stu, they're not one use case. You've clearly got 2 use cases called out in the chart there. But really, error handling is a subcase of rebinding, and I think the reason that Rich called it out yesterday is because it was a motivating use case for him when he designed it. And so, but those 2, and the flip side of that is, if you can come up with a motivated argument for where those would ever be different, then we're not simple enough yet. And this is a perfect example of the kind of design thing that Rich was talking about when you're analyzing what you were thinking when you woke up. I think these 2 things are the same. They're really part of the same simple. They're not a compound. I don't need to tease them apart any further. I'm done. But I did have 2 kind of use cases, so let me just sort of document that. Structure. Clojure delivers structure a la carte. And so you have this ability to say, I'm going to have a map, and I'm going to do all my map stuff with it. Keyword access, nested access, what have you. And I can switch to records, and records just deliver structure, right? Records document structure, but do nothing else. So records have first name, last name, address, whatever, right? That structure delivered a la carte without any ancillary stuff. And the API remains the same, right? All the calls, right? Everything is still data. It still looks like maps. Now, this is the point in the talk where I have lied to you. Because records don't really deliver structure a la carte. What do they deliver? They deliver type, and they deliver all kinds of stuff, right? They implement all these Clojure interfaces. And so, thinking about records for a while, you might realize that there's something simpler underneath. There's a distinction between data as information, right? Which is what records are for, and mechanism. And so you end up having def record being built on top of a simpler thing, def type, right? And def type really is a simple thing. And the only ways in which def type is not simple, you start talking about getting type and field access in the same go, that's actually, pretend like that didn't happen. We'll talk about it in a minute. So, what's the most important thing to do if we're thinking about using simplicity as an organizing metaphor for how we think about designing good code? Looking at Clojure for inspiration, wanting to do this in our own code. What Rich said in his talk is that who needs to be a really harsh criticism of this thinking? We do. Right? If we're going to look at this and say, we think this is good, we need to use that waking mind and ask ourselves, what trade-offs do you make in the name of simplicity? Because all those things that I named earlier, all those things that people called simplicity that weren't, were valuable. They just weren't simple. And the first thing I want to say about this is that there are no trade-offs in defining simplicity, right? In this talk, I'm squatting on the correct definition. Simple equals not compound. All the definitions that I gave earlier, all the definitions that come out of the pathos from uncomplicated to easy to simpleton and all that stuff, those are literally follow-on definitions. They are not the original definition. More importantly, simplicity is fundamental. It's literally fundamental. If you look in the dictionary, one of the definitions of simple is fundamental. So I win, right? We get to keep, we get to keep this. What does fundamental mean? Yeah, it does mean simple, right? It's at the bottom. In what specific sense? What other word in English is related to fundamental? Foundation, right? So it comes from Latin fundamentum, right? It means the foundation. And the point that I'm making here, and by the way, again, I'm going to have to make, this is going to be your Socratic homework assignment. So you need to have a Socratic dialogue with yourself in which you pick any of the other definitions of simplicity from the beginning of this talk. So easy to learn, or made of a small number of pieces, or minimal, and make that your foundation. And then try to build stuff with it, right? Try to design stuff with that as your foundation, and then try to get to simplicity as a follow-on or a derivative concept and see how that works for you. And then try it the way I'm recommending is the correct way, which is make simplicity your foundation and design things that way and see where that gets you. And if I had an extra hour, I think I could have a lot of pathos-appealing slides to make a stronger argument or a stronger emotional appeal that making simplicity the foundation is the right way to go. But try it for yourself. Now, I've just actually performed another rhetorical trick because I told you that I was going to talk about trade-offs, but what did I then do? I said this is not a trade-off. Right? There's no trade-off made here. There was no alternative choice for a design method. There was no other goal other than simplicity that I was comparing it to. I used it as a rhetorical trick to go back and just piss on the other definitions of simplicity one more time. But there is a really big trade-off that Clojure makes that compromises simplicity, and it's systemic, and it's painful. And what is it? It's living on the JVM, right? It's living on the JVM. So why did Rich make this trade-off? What does the JVM give us? It gives us performance, it gives us power, it gives us reach, right? We're not Lisp, we're not on an island. The JVM trade-offs include primitive operations, conforming to the Java collection APIs, lack of tail call optimization, weird OO interop forms that don't represent how to do work the right way but are necessary, so gen class and proxy, alternate numeric operations, unchecked integer math, and so forth. And these bubble up to more painful and more perhaps regularly occurring API trade-offs. If I'm consuming a Java API, I may still have to deal with uncontrolled mutation. I will have to deal a lot with premature abstraction, right, which we remove. That's called destracting, de-stracting, right? Going back and getting rid of abstraction and turning things back into sets and maps. I have to deal with implementation inheritance, annotations, and pattern bloat. And I put bloat there with a question mark because I would normally make the argument that patterns are just bad, period. But that requires another hour, so we'll just say that too many patterns is bad, and then you can all agree with that because it's in the definition of too many. And then you get ecosystem trade-offs. So there's a presumption in the Java world of binary delivery. That's pretty hostile, right, to a Lisp. Right? We don't really need to have compiled binaries match up with each other, but it causes pain points. Inferior serialization. We're spending time worrying about XML and JSON APIs. Version linearity. This is actually an ecosystem trade-off that everyone's dealing with right now. Right? This is actually probably doesn't really fit in this slide, but I wanted to mention it because it's an issue. Right? There's a presumption of version linearity in how we deal with deployment, and that's not really true with Git anymore. But there are a lot of tools that think that. And then, living in the Java ecosystem, we actually have to wrestle with a lot of tool sub-ecosystems. Right? So it now works on NetBeans and it doesn't work on Eclipse. And tomorrow we get it working on Eclipse and then it doesn't work in IntelliJ IDEA. I mean, this is the pain-reward trade-off for being on a big platform where lots of things happen. So, there's a ton more I would like to say about the ecosystem trade-offs. There are a lot of specific things that we do in ecosystem trade-off land that are complex and complicated because we're on the ecosystem, and we have to make really hard design choices. And I think there are really fun conversations here, and they are around things like how Leiningen lives on top of Maven. Those kinds of questions. There's a lot of interesting stuff that happens there. We're going to have to save it for beer and barbecue. The other thing I want to talk about is using this to improve your own designs. So it's great that, to some degree or not, that Rich has drunk from the well of simplicity and has visited Clojure on us. But I want to be more than just a consumer of these benefits. Right? I don't want to have a superficial head start using Clojure just because there's a bunch of good stuff already there. I want the things that I write and the things that other people in the community write to also embody this kind of simplicity. And so there's kind of a, and now this is, I'll call this this is opinion subjective portion of the talk. There's kind of a formula you might follow. That's right, everything else was fact. Fact. There's a model you could follow to try to make things simple. And I'm going to walk through this in the design of a specific API. So broaden your context, tease apart known compounds. So when there's something already floating out there that's a compound, break it apart into simples. Find new simples. Go directly to data. Sleep on it. And I'm going to go through these steps in the design of a specific API and how we got there. So when Clojure went to 1.2, I made a great effort, and other people in the community made a great effort, to get a bunch of things in Contrib promoted into Clojure so that certain projects wouldn't have as many dependencies into Clojure. And one of the things that didn't get there is a wonderful little function that Chowser wrote called show. And what show does, Rich is putting his head in his hands. Yet again, Rich looks at Chowser's code and puts his head in his hands. So what show does is gives you reflective introspection over the Java thing you're working with. I think Clojure is a kick-ass environment for exploring Java libraries. And I'm not the kind of guy that goes to Javadoc. I'm much more likely to look reflectively at objects and understand what they do. So I wanted this, and I proposed that we promote it forward, and Rich put his head in his hands, just like he just did. And the problem here is that this API is, well, let's walk through the issues and see where we end up. So, broader context. It turns out that the compiler needs reflection too. So if you're going to write something that's going to be reflective, it's not just REPL consumers, right? You have to think about other potential consumers. And this is one of the things you might not know unless Rich just told you. Some users of reflection don't have classes in hand. Other users of reflection must have classes in hand. Java APIs for reflection can't be instantiated by normal code. I can't create a java.lang.method. or Java lang reflect method, or a Java lang reflect field. The only thing I can do is get them from a class, which means that they are not useful as a baseline for reflection if my goals include people that don't have a class in hand and people that do have a class in hand. So the first cut that I took at writing code that would solve these problems worked as follows. There was a REPL API designed to replace Chaucer's show called describe, which called a more data-driven API. So I'm calling down to something simpler, reflect, which had a pluggable implementation via a protocol that allowed me to use different reflectors, in particular to handle the different use cases of people who have a class in hand or people who don't. A set of predicates were used to limit the results, and then a REPL format protocol printed things out as a table. And so now you got a reflection API that looked like this. Describe string named last. And so this finds java.lang.string. The print output tells me things that start with last, and then prints out all the things. Am I being inadvertently funny now? What's that? Oh, his head in his hands again. Yeah, so this is the first design that I showed Rich. And that was painful. So this does not suck compared to a lot of stuff that's out there. I mean, there are several things. It doesn't. Right? There's a nice little mini DSL for describing, and it wasn't just named, there were a bunch of little predicates and lots of little helpers so that all the REPL use cases were covered. And this actually did cover the REPL use cases and the compiler use cases. But iterating through it, we said, okay, maybe this is still compound, given that the whole point of this talk is using simple as a design principle. This is still compound. What things are conflated in here? Well, there are multiple entry points, both describe and reflect. Is that really necessary? Right? If we can find a world in which there's only one entry point, that would be better. There's explicit wiring. Right? So the API actually had slots in it where you dropped in the next step, and then slots in it where you dropped in the next step. There were specialized matchers. Specialized matchers feels like failing on the promise of having general data. And there was custom printing at the end. And so the next round, which is currently in, and looking for feedback, was that there's a single function reflect, which uses the reflector protocol. That part was good. Generic wiring. And the generic wiring is already in Clojure, right? I don't need to have all these little API slots to channel one thing to the next. We could just use the arrow operators. Predicates are just generic functions, right? There's no special thing there. There could be a really cool Clojure.data.match that did that, but there's not there now. And then another simple print table. So instead of having something that could print out a nice tabular representation of reflection, how about something that prints out a nice tabular representation of what? Anything. And so the new version looks like this. You arrow reflect java.lang.string, you grab the members, you filter with anything you want, you print table. Now, this is not as concise as the inferior API, but it would be if we had Clojure.data.match. Right, we'd have a way to do matches in the middle, and that would be fully composable. And the big thing here is what was originally a compound of solving the reflection part, which was done okay, and doing the filtering, which was compounded in unnecessarily, and doing the printing, which was compounded in unnecessarily, has now been realized in 3 separate pieces, one of which still represents work to be done. So one of the reasons that I jumped to the wrong way to do it is I wanted to kind of solve the complete problem. And one of the things that falls out of wanting to be simple is needing to be a little bit more patient. So the practices that we saw here, broadening your context, asking who the other users were, teasing apart known compounds, right? So finding out that printing and filtering and all those things were separate items, looking for new simples, getting straight to data, and several iterations of sleeping on it without having any alcohol, or how to get there. It's really good. Newcastle. So there's a ton more I would like to say about this. One thing I'd like to say is I do think that there are other things that compete with simplicity as a decent foundation, as a decent place to start, and I think there's interesting discussions to be had about that. But we're done. We are at the end of our time here.